Problem Introduction. Hey everyone, and welcome back to the channel. Today, we're tackling LeetCode problem number 20, valid parentheses. This is a classic problem, often asked in coding interviews, and it's a great way to practice your dynamic programming skills. The problem statement is simple. Given a string containing only parentheses, open and close round brackets, square brackets, and curly braces, determine if the input string is valid. A valid string means that every opening parenthesis has a corresponding closing parenthesis of the same type, and they are nested correctly. For example, open parenthesis, open square bracket, close square bracket, open curly bracket, close curly bracket is valid. But open square bracket, close parenthesis is not. We need to return true if it's valid and false otherwise. We'll be focusing on an efficient solution, so let's dive in. Understanding with examples. Let's solidify our understanding with some examples. Open parenthesis, close parenthesis. That's valid. Simple, right? Now, open square bracket, close square bracket. This is also valid because each opening bracket has a matching closing bracket in the correct order. How about open curly bracket, open square bracket, open parenthesis, close square bracket, close curly bracket? Yep, valid again. Nested structures are fine as long as the pairings are correct. But let's look at some invalid cases. Open square bracket, close parenthesis, invalid because the opening square bracket closes with a parenthesis before the square bracket itself. Similarly, open parenthesis, close parenthesis is invalid, and open square bracket, close parenthesis is invalid. These examples should give you a good grasp of what we need to identify. The key is matching opening and closing parentheses correctly and in the correct order. We'll explore a systematic way to solve this problem efficiently. Brute force approach. One naive approach would be to use nested loops to check for every opening parenthesis if there's a corresponding closing parenthesis later in the string. We could iterate through the string, and for each opening parenthesis, we'd search for its matching closing parenthesis. However, this brute force method would have a time complexity of O of n squared, which is quite inefficient for larger strings. The search operation within the loop dominates the runtime, making it slow. Imagine a string with thousands of parentheses. That's a lot of nested iterations. We can do much better with a more clever strategy that doesn't require nested loops. Optimal solution. The optimal solution uses a stack data structure. We'll iterate through the string. When we encounter an opening parenthesis, we push it onto the stack. When we encounter a closing parenthesis, we check the top of the stack. If the top of the stack is the corresponding opening parenthesis, we pop it. If the stack is empty or the top element doesn't match, we know the string is invalid, and we can return false immediately. After iterating through the entire string, if the stack is empty, it means all opening parentheses were correctly matched, and the string is valid. This approach avoids nested loops, making it much more efficient. Code implementation. Let's see the code in Python. We'll start by creating a stack. Then we loop through the string. For each character, we check if it's an opening parenthesis. If so, we push it to the stack. If it's a closing parenthesis, we check the stack. If the stack is empty or the top element doesn't match, we return false. Otherwise, we pop from the stack. Finally, we check if the stack is empty. If it is, the string is valid, and we return true. It's concise and highly efficient. Remember to handle different types of brackets correctly in your matching logic. Time and space complexity. Our optimal solution using a stack has a time complexity of O of n, where n is the length of the input string, because we iterate through the string once. The space complexity is also O of n in the worst-case scenario, where the stack could potentially hold all the opening parentheses if they're not matched until the end of the string. This is a significant improvement over the brute force approach. This linear time complexity makes it ideal for handling large input strings efficiently. It's much faster and more scalable compared to the O of n squared approach. Engagement break. Before we wrap up, don't forget to give this video a big thumbs up if you found it helpful. And if you want to stay updated on more LeetCode solutions and coding tutorials, hit that subscribe button and ring the notification bell. Also, let me know in the comments what other